The engine that has been holding Earth's magnetic shield together for 3.5 billion years just did something it was never supposed to do. 5% of the molten metal at the core beneath the Pacific Ocean reversed direction 16 years ago and held the reversal for almost a decade. The atomic clocks recorded it. The magnetic field recorded it. The inner core itself was physically reshaped by it. And the same window contains the worst run of magnitude 8 earthquakes ever measured, including the cluster still active right now on 2 coasts of the Pacific. By the end of this video, you will know what the engine is doing, what the data actually says about the connection, and why the average citizen should know about this. Let's go. 16 years ago, in the spring of 2010, the engine at the very center of this planet reversed direction. Approximately 5% of the molten metal in the outer core, in a localized region directly beneath the Pacific Ocean, stopped doing what it had been doing for the entire instrumental record and started moving the wrong way. For decades, the outer core's surface flow had drifted westward, slowly, steadily, boring. Textbook. And then, sometime around the spring of 2010, in one specific region, the flow reversed. Westward to eastward, 5% of the total, a localized counterflow, and it held that pattern for nearly a decade. The confirmation arrived in the spring of 2026. A research team led by Frederick Dalmatson combined the European Space Agency's Swarm satellite constellation with the Global Seismic Catalog and produced what the geophysics community had been waiting on for almost 5 years. The Swarm record gives a continuous high-precision measurement of Earth's magnetic field from satellite altitude. Combined with the older Ørsted and Champ records, the time series runs from 1997 through the present day. The seismic catalog inversion told the same story from a different direction. The 2 data streams converged. The reversal is real. It is localized. It is sustained. And right now, since approximately 2020, the reverse pattern has begun to weaken, but it has not gone away. 5% of the outer core's surface flow is not a small number. The outer core is 2,260 kilometers thick. It is a layer of liquid iron at approximately 5,000 degrees Kelvin, weighing roughly 1.8 quintillion kilograms. Its surface flow is normally organized at the largest possible spatial scales, single coherent patterns spanning continental fractions of the planet. To produce a localized counterflow at 5% of the total, you have to physically reorganize the dynamics, the buoyancy, the Coriolis force, the interaction between the flow and the magnetic field. Something inside the engine that has been holding our magnetic shield together for 3.5 billion years did exactly that 16 years ago, and we are still working out what it means. The atomic clocks noticed. In 2010, the International Time Standard, Coordinated Universal Time, the standard that synchronizes GPS, financial systems, satellite navigation, and global communications, recorded a small but real change in the length of the day, a fraction of a millisecond. Far too small for any human to perceive. The sun came up at the same time. Your watch did not skip. Your day ended exactly when it always did. But the cesium atomic clocks that define international time are accurate to 1 second in 300 million years, and they registered the change immediately. The mechanism is not exotic. It is not contested. It has been understood since the second half of the 20th century, worked out in detail by Matthew Dunbury and Jeremy Bloxham in 2006, and refined by Richard Holm and Olivier de Viron in 2013. When the outer core reorganizes its mean flow, the angular momentum carried by that flow has to be conserved. The mantle, sitting directly above the outer core, has to compensate. Because the mantle is much more massive than the outer core, the compensation produces a small change in mantle rotation rate, a fraction of a millisecond, measurable by the atomic clocks. Every single time, the 2010 length of day signal is the mantle responding to the outer core flow reversal Dalmatson's team just confirmed. Same year, same engine, same coupling. 2 independent measurements of one event. And it gets worse. In 2017, the magnetic field itself did something. Geomagnetic jerks are abrupt kinks in the magnetic field's secular variation, sudden changes in the rate of change over months instead of centuries. They have been recognized since the 1960s. They occur every 5 to 10 years on average. But the 2017 jerk was the strongest jerk ever recorded by satellite. A paper by Julian Aubert and Christopher Finlay in 2019 traced jerks to buoyancy-driven waves moving through the outer core, originating in approximately the same region the Dalmatson team has now identified as the location of the flow reversal. The same region, the same window, the strongest signal in the satellite era. 3 measurements: the flow reversal, the length of day anomaly, the geomagnetic jerk. Same engine, same window, same coupling. Inside the fluid outer core, at the very center of the planet, there is a solid iron sphere about 1,200 kilometers in radius, about 70% of the radius of the Moon. It was discovered in 1936 by a Danish seismologist named Inge Lehmann in a 2.5-page paper titled simply P, after the seismic phase that proved the inner core was solid. For most of the 20th century, the inner core was treated as a frozen object slowly growing, slowly rotating, otherwise unchanging on human timescales. That picture is no longer current. A recent study analyzed 168 pairs of repeating earthquakes. These are pairs of small earthquakes that hit the same exact fault patch at different times, producing essentially identical seismic waves at the source. Any difference between the two waveforms recorded at a distant station, then, has to come from something that changed between the two events along the path. The waves traveled, including the inner core. By carefully selecting pairs where the inner core would have been at the same rotational position during both events, the study ruled out rotation rate change as the explanation for the observed waveform differences. The differences are real. They are not rotation. The most defensible interpretation is that the surface of the inner core itself is being reshaped meter-scale depressions and uplifts at the boundary between the solid inner core and the fluid outer core on timescales of years to decades. The implication is direct. The solid iron sphere at the center of this planet is structurally soft enough to deform under the pressure variations the outer core exerts on it. The fluid above is physically reshaping the solid below by meters over a single decade. The same outer core whose flow reversal we just walked through is also reshaping the inner core. The coupling is not abstract. It is mechanically real. And if it is strong enough to deform the densest object on Earth from below, it is propagating signal in every direction it can propagate signal. Down to the inner core, where the evidence is on the record, and up through the boundary, through the mantle, toward the surface. In 2024, a team studying the chemistry of Hawaiian volcanic rocks found something that should not have been there. Specifically, they found isotopic ratios of a heavy element called ruthenium, the relative abundances of ruthenium-100, ruthenium-101, and ruthenium-102, consistent with a source at the core mantle boundary, not at the upper mantle. The signature was at the level of 3 standard deviations against the mantle baseline. The physical pathway, trace amounts of core material entrained into the base of ascending mantle plumes, carried roughly 2,900 kilometers vertically through the densest part of Earth's interior, erupted at the Hawaiian Islands. It is the first observational evidence of a direct chemical pathway from the core to the surface. This matters for one specific reason. For the entire 20th century, the textbook treated the core mantle boundary as essentially sealed. The deep interior was a closed system, and signals from the core could not meaningfully reach the surface. The Hawaiian ruthenium signature is the first piece of evidence that the boundary passes signal, chemical signal, at trace levels, but signal nonetheless. And once you know that the boundary passes signal in one form, the prior probability that it passes signal in other forms, mechanical, angular momentum, electromagnetic, goes up. A sealed core is one kind of physical system. A leaky core is a completely different kind. And what the leaky core can do on the integrated decadal timescales the rest of the evidence is now pointing at is exactly what we are about to walk through. Here is the part that, until very recently, almost nobody outside a few specialized research groups was putting together. The same 15-year window that contains the outer core flow reversal, the length of day anomaly, the geomagnetic jerk peak, and the inner core shape change, the same window contains the densest sequence of magnitude 8 and above megathrust earthquakes in the entire instrumental record. The events: Sumatra, Andaman, 2004. magnitude 9.1 to 9.3. Nias 2005, magnitude 8.6. Pisco, Peru, 2007, magnitude 8.0. Bengkulu, 2007, magnitude 8.4. Samoa, 2009, magnitude 8.1. Mal, Chile, 2010, magnitude 8.8. Tohoku, Japan, 2011, magnitude 9.1. Iquique, Chile, 2014, magnitude 8.2. Illapel, Chile, 2015, magnitude 8.3. Chiapas, Mexico, 2017, magnitude 8.2. Approximately 14 magnitude 8 or larger earthquakes in 15 years. The long-term Poisson expectation over the same window is approximately 7. The cluster is real. The statistical significance is approximately 2 standard deviations on a straightforward Poisson rate test, up to 3 standard deviations with the most defensible window choice. Pure chance cannot be ruled out, but pure chance is not the most defensible reading either. This channel covered the cluster statistics in detail in our climate seismicity video from May 30th. We laid out 3 credible candidate mechanisms for what could be modulating the rate. Cryosphere, mass loss, Greenland, Antarctica, and mountain glaciers combined are losing about 700 gigatons of ice per year, and the load redistribution as the continents below them rebound is enough to modestly modulate fault stresses. Sea level loading on continental margins, rising at about 4 to 5 millimeters per year. Groundwater depletion in major aquifer systems, Central Valley, the Ogallala, the Middle East measurable in satellite gravity data. We explicitly rejected solar seismic causation on energy budget grounds. We rejected HARP on the same 15 order of magnitude energy gap argument. 3 mechanisms. Real, but small. None of them alone fully explained the cluster. What we could not yet name, 10 days ago, was a 4th mechanism. Because the synthesis of the deep interior evidence had not yet been done in the public literature with enough clarity to fold in honestly. The pieces were there. The picture had not yet come together. The picture has now come together. And the 4th mechanism is the one the rest of this video is about. The mechanism, in plain language, works like this. The outer core reorganizes its mean flow. The reorganization changes the angular momentum carried by the fluid core. Because the planet is a closed mechanical system, angular momentum has to be conserved. The mantle, sitting directly above the outer core, compensates with an equal and opposite change in its own rotation rate. We see that change in the atomic clocks as a fractional millisecond length of day signal. The mantle's rotation change applies a small, uniform torque to everything sitting on top of the mantle, including the lithosphere, the tectonic plates, and every fault on the planet. The torque does not target any specific fault. It does not exert force on a particular spot. It applies a planet-wide, uniformly distributed, small adjustment to the global stress budget. Faults that were already near failure get nudged into failure slightly earlier than they would have otherwise. Faults far from failure are unaffected. The net effect, integrated across the entire global fault network, is a small modulation of the global rate of large earthquakes over 5 to 10-year windows. The mechanism does not predict any specific earthquake. It does not predict which fault. It does not predict when, at the level of a particular event. It modulates the rate. The key citation is a paper by Roger Bilham and Rebecca Bendick, published in 2017 in Geophysical Research Letters. The Bendick and Bilham paper reported a statistically significant correlation between Earth's rotation slowdown, which is itself driven by core mantle angular momentum exchange, and the global rate of magnitude 7, or larger earthquakes on a 5-year lag. The correlation was modest. It did not predict individual events. It modulated the global rate by a few extra magnitude 7+ events per year above the long-term mean during periods when the rotation was slowing. A few extra events per year, integrated across the planet over a decade, adds up to approximately the magnitude of the 2004 through 2018 cluster excess. The mechanism does not invent earthquakes. It shifts the timing of ones that were already going to happen, slightly forward in some windows and slightly backward in others. It is small. It is real. It is admitted in the peer-reviewed literature, and it joins cryosphere mass loss, sea level loading, and groundwater depletion as the fourth credible candidate for what modulated the densest stretch of magnitude 8+ earthquakes in the instrumental record. It is also the only one of the four that operates from the bottom of the system upward, rather than from the top down. It is worth being precise about the magnitude, because the size of the effect matters for how you interpret the rest of this picture. We are not talking about a mechanism that doubles the earthquake rate. We are not talking about something that could turn a quiet decade into a catastrophic one. We are talking about a mechanism that takes a 5-year average rate of roughly 10 to 15 magnitude 7 and above earthquakes per year globally, and modulates it up or down by a couple of events per year depending on what the rotation is doing. Across the whole planet, across the entire fault network. A few extra events here, a few fewer events there. Accumulated over a 10 or 15-year window, that small modulation produces the kind of cluster excess we just walked through in the 2004 through 2018 window. It does not predict the next earthquake. It does not change the hazard assessment for any individual fault. It is one of 4 credible mechanisms operating in parallel cryosphere: sea level, groundwater, and now the engine at the center of the planet, each contributing a small piece to a combined modulation that we are only now learning to detect. And the part of the planet where the deep interior reorganization happened most strongly is geographically the part where the present-day earthquake cluster is unfolding. We are recording this on the night of June 5th, 2026. The seafloor off Cape Mendocino is still adding events. The cluster that hit the southern Cascadia margin 2 nights ago, the magnitude 5.7 west-southwest of Pistol River, Oregon, the magnitude 5.1 offshore Petrolia, California has not finished its aftershock decay. The Pacific Northwest Seismic Network catalog is still being updated. On the opposite corner of the Pacific Plate, the cluster that hit the Kuril-Kamchatka Trench segment is also still developing. The Russian Academy of Sciences regional stations are still recording. The most recent reported event was a magnitude 5.1 at 1713 hours, universal time yesterday. Both clusters are alive. Both segments are loaded. The Cascadia southern terminus is past 100% of its paleoseismic recurrence interval. The southern Kuril-Kamchatka segment is under active Japan Meteorological Agency megaquake advisory following the 2024 magnitude 8.8 rupture that left the neighbor segment exposed. And the Pacific outer core flow reversal that Dalmatson's team confirmed sits geographically beneath the same Pacific Ocean. The same plate whose 2 opposite locked margins are currently adding catalog signal in the same 48-hour window. The geometric coincidence is real. The mantle filter is also real. Roughly 2,800 kilometers of solid silicate rock between the core mantle boundary and the base of the lithosphere, which destroys the fine spatial structure of any signal originating below. A reverse flow region under the Pacific cannot produce a precisely localized stress signal at the Pacific Plate's margins. The honest reading is that the geometric alignment is most likely coincidence. But the coincidence is suggestive enough that the field is examining it openly, and dismissing it without examination is not the right intellectual posture. The cluster on the American coast is still developing. The cluster on the Russian coast is still developing. The engine that may be modulating the global rate is the same engine sitting directly beneath both of them. We do not yet have the instruments to say whether the engine is producing a Pacific-specific signal or only the integrated global modulation. The next decade of measurement is going to tell us. The Pacific outer core flow reversal has been weakening since approximately 2020. The post-2018 global megathrust rate has dropped back toward the long-term Poisson mean. Both timelines point in the same direction. If the fourth mechanism is operating at the magnitude the Bendick and Bilham correlation implies, the modulation envelope that elevated the rate during the 2004 through 2018 window is now decaying back toward baseline. That decay is exactly what we should expect to see if the integrated coupling interpretation is correct. The next decade of European Space Agency swarm satellite data will tell us whether the reversed flow continues to weaken or stabilizes at some intermediate pattern. The next decade of broadband seismic data will tell us whether the inner core shape change is continuing, accelerating, or fading. The next generation of diamond anvil cell experiments will refine the inner core composition picture and possibly identify additional light elements beyond carbon and silicon. The next round of mantle plume geochemistry studies will test whether the Hawaiian ruthenium signature is unique to Hawaii or whether other hotspot chains, Iceland, the Galapagos, Reunion show similar core mantle boundary chemical signatures. The next set of statistical analyses of the global earthquake catalog will either confirm or revise the Bendick and Bilhem correlation. In the meantime, the seafloor off the American Pacific Northwest is still moving. The seafloor off the Russian Far East is still moving. The Cascadia southern terminus is still past its recurrence interval. The Kuril-Kamchatka segment is still under active megaquake advisory. None of this predicts the next earthquake. The fourth mechanism does not predict individual events at any timescale. What it does is name a real, peer-reviewed, instrumentally documented coupling between the engine at the center of the planet and the plates that ride on the mantle above it. A coupling that for the entire 20th century, the textbook treated as essentially zero, and that for the entire 21st century, the instruments have been steadily showing is not zero. The engine is reorganizing. The coasts are responding. The textbook is being rewritten in real time. And the next chapter of this story is going to be written by the next decade of measurement that the satellites, the seismographs, the diamond anvils, and the geochemistry labs are going to produce. We will be tracking this as it develops.